Hit it!
That's what I'm talking about.
Wait!
Okay, now, from the beginning.
All right, let's get to it. First of all, thanks a lot for coming. Welcome to Unity at GDC. As you guys might have noticed, the office is pretty decked out. It's exciting for all of us who are based here in San Francisco, and we're all anxiously awaiting to see how much of it we can keep. My name is Dan Miller. I work at Unity Technologies as an XR evangelist. That means I focus a lot on augmented and virtual reality, traveling around, giving workshops. I come from a game programmer background, so I do a lot of demo development and things like that. That's my email. If you guys have any questions, I also have cards. I forgot cards yesterday, so I can give those out. If you guys are trying to follow up on anything we see here, any AR, VR related stuff, or just general Unity things, feel free to hit me up. And I just wanted to call out for this workshop specifically. This was made kind of in partnership, mostly on the Google side by Clayton, and just wanted to call him out to give him some credit for what we're going to do. So this is a Google Codelab. If you're familiar with Codelabs, they're basically kind of a set of little workshops that you can work through. This one is fairly we're doing some kind of basic things in ARCore, but I think that there's a lot of core understanding and knowledge that you'll gain from this. And there's also a lot of kind of helper scripts and things that you can then use outside of this project, or just to understand how things work and take advantage of those a little bit more. So the overview for today, I'm going to give a small overview of what ARCore is, what it does, show some of the apps that I've built on top of it, and go through the Android development stuff. That's what I've kind of been helping with you guys so far. Preparing your device to be ARCore ready. I think I might just glaze over that because if you're not aware, ARCore was officially released a couple weeks ago at Mobile World Congress in Barcelona. So 1.0 is officially out. You can now kind of publish an app on the Google Play Store using ARCore. And then we're going to get into the workshop. So I did this exact same workshop yesterday. It was a bit of a trial run. So you guys are the version 2, which should obviously be better. So we'll see how that goes. There is some places that I got caught up when I was kind of developing it, and so I'll be able to point those out, hopefully guide you guys along. But we are going to be, building APKs, building up the SDK, kind of doing some fundamental development in Unity, as well as writing code. One of the ways that the workshop is going to work is through these things called learning cycles. And what I'm going to do for that is that I'm going to go on my machine. I'm going to basically work through the workshop. Actually, I just forgot that I didn't set something up. All right, perfect. This is still in here. So I'm going to work through the basically kind of steps or process on my side. Then what I'm going to do is just run through them one more time quickly, show it up on a slide, and then that's when you guys are going to work through it. So it's more of like a watch, observe, absorb. Then you guys can work through it, and then I'll be able to kind of come around and assist you. All right. So let's go ahead and get started. What is ARCore? So ARCore is Google's mobile AR solution. It is basically a SDK that allows some kind of core processes to be happening on Android devices. It's Android specific. It's made by Google. The supported devices right now are a bit limited. It is only working on the kind of flagship phones made by Google, as well as some of the Samsung phones made through the partnership. A big push for Google is going to be trying to roll out support for additional phones and hardware. The core functionality of the ARCore and kind of the fundamental concepts are things like motion tracking. And so this is using device IMUs. So IMUs are things like the gyroscope and accelerometer. And if you're a phone manufacturer, what you can do is you can calibrate your gyroscopes and accelerometer at the manufacturing process in order to be ready for kind of the ARCore supported devices. So that's what some of these companies, Google themselves, have been doing for the last couple of years. But as you imagine, with the wide plethora of Android phones made around the world, some of those don't go through the calibration process, so the accuracy and tracking on them is not as high. So motion tracking. Another thing is that these devices become 6DoF devices. So 6DoF stands for 6 degrees of freedom. And what that means is that once a device has established itself in the space, the position and rotation of the device is kind of known as a factor within Unity. This means that you can walk around and kind of trace your motion path with the device. This means you can query how close your device or camera is to an object to trigger interactions and things like this. And I think this is going to be an important factor when kind of thinking about and designing interesting interactions in the mobile AR space, is making sure to remember that your device is kind of tracked in the world here. Next one is environmental understanding. So ARCore right now specifically handles plane finding on a horizontal level. So it cannot find vertical planes. It can only find horizontal planes, things like the floor, certain desks, and stuff like that. In this room specifically, these desks are super kind of shiny, and there's lots of bright lights above us. So we did notice yesterday that there is some difficulty with finding planes on top of here. If you have some stuff, like this free stuff that you got when you got here, you can kind of scan this and potentially find a plane there, as well as use the floor. The floor is not the best as well, because you can notice that it's just kind of a solid dark gray color. So oftentimes when we're doing ARCore demos and things like that, we'll get like an interesting rug or something, because really it's using computer vision along with these IMUs to kind of establish itself in the world and understand a little bit about its environment. The next thing is feature points. So feature points are basically kind of interesting things that the computer vision algorithm can link onto. With ARCore in its 1.0 release, it now has something called oriented feature points. And what this means is that when it finds a feature point on an object, it can kind of sample the feature points around it and place an object at certain angles relative to where that feature point is. If you're familiar with 3D modeling, it's kind of like something like an object normal. So if I were to locate my laptop here, I could use an oriented feature point to kind of place an object on the side here. I could also do a similar thing for a wall, but again, it's not supporting vertical planes right now, it's only doing horizontal. And last but not least is light estimation. So the frame that you're looking at through your device is able to return back an ambient light value. The obvious use case for this is to shade or brighten your models based on where they are and kind of the light value from that. So if you're in a dark room and you're starting to place objects in the world, you can use special ARCore shaders that actually make those a little bit darker. And then if you turn the lights on, they get lighter. All right, so any questions about ARCore? Sweet, I gave a perfect explanation. So what I'm gonna do now is show some demos that I made. And this is gonna blink a little bit, so I apologize for that. But I'm gonna walk through some of these and hopefully you guys will see some cool stuff. So the first one I'm gonna do, let's go right here. Bam. All right, the first one I'm gonna do is breadcrumbs. So what I'm doing here is, when I start up, I'm going to kind of be looking at the floor here. And when I've established the floor, I'm just gonna hit this start button. And when I walk around, what I'm doing is I'm actually placing little objects behind me on the ground. So when I stop and I turn around, you can see that the path I walked is now kind of recorded. And what I'm doing here is I'm basically, using the position of the camera and just saying, hey, if I'm a meter away from the last one, drop one behind me, put it on the plane that it's on. And now you can see these are kind of tracked. I could be walking through a forest and maybe I got lost, but I was kind of recording myself here. And then you can just go through and kind of retrace your steps. So this is something we have there. Next one I'm gonna show, let me go ahead and close that out. All right, so this one is called Cuties. What this does is, one of the things that I believe is a good kind of differentiator between an awesome ARCore app and a not so awesome one is the ability to render planes with like a custom texture and custom material. So you can see here we have lots of hearts. It's a little bit blinking there. So instead of using the default plane renderer, which we will be using in our workshop, you see I've kind of modified this a little bit. And what I can do is I can place little guys down there, and then when they get close to each other, they kind of spawn some hearts. Another thing I'm doing here is, you'll notice when I get really close that it does a blink and then a wink. So the wink is triggered if you're actually really close to it. So let's see it there. There he does that. So again, I'm kind of sampling how far away I am from the object, just using this as kind of a tracked device. This is just literally a game object in Unity. You can kind of do a quick distance check from there. All right, and the last one I'm going to do, this may or may not work. I need to update this. What I'm going to try to do is take advantage of some of the oriented feature points here. Let's see what we get. All right, so there we go. So what I've done is I've placed two objects. I realize I'm standing in front of the screen. I placed two objects on the back of my computer here. And because the way AR rendering works, you can see I can kind of line it up with the exact position, but then I can go around to this side. Might see some inception. Oh, no. And then I can actually see kind of the exact location through my computer. So it's kind of like an X-ray vision through my computer, because the way AR rendering works is that everything renders on top. You see, I can't actually occlude anything because it renders last on top of the camera feed. All right. So those are some things I worked on. I did do a blog post a week or so ago. If you guys are interested in that, you can go to blogs.unity3d.com, and that's going to show some of the work that I just showed you there, as well as some more detailed explanations. Any questions on that stuff before I move on? Sweet. You guys are excited to get going. Here we go. So Android mobile development. Talked a little bit about this. You don't really need the Android NDK. That's if you're converting your C# to C++ for a little bit faster or smaller runtime. But you do need the Android module. I think almost everyone either came in with it or is already getting it started. You don't need the developer tools for sideloading the ARCore APK because it's officially released now. This was when it was in developer preview. But if you are doing any sort of Android development, I highly encourage you to check out ADB. It's basically Android Debug Bridge and allows you to query what's happening on the device, give back some information, things like that. All right, getting started. So what we're going to do here, let me cue this guy up here, is, oh, actually one more slide, forgot about this. So you guys need to go and download one more thing. This is a Dropbox link. I think it's still working. It is case sensitive, so if you guys can go ahead and get that now, it's going to be 2 Unity packages, and I'll walk through the process of importing those into your project. But just go ahead and start the download now. And if someone can tell me that it is working, that would be appreciated. It's working, sweet. Yep, download both. Should be 2. So one of the packages you have is basically the ARCore SDK. That SDK for Unity is available on their GitHub. This is just a kind of a packaged version of it. And then the other one is going to be the assets that we're building on top of. Some of them is code that I've written, and there is an error right away, so we'll go ahead and fix that briefly here in a moment. Do you have a question? Cool. What else was I going to say? Yeah, if you're not familiar, Unity packages are just kind of glorified zip files that are basically Unity assets that have been serialized for the Unity engine here. So it's just kind of a collection of assets. Everyone good on this link? Sweet. I'm going to need, you're good? Okay. Okay, you got another thing? So yeah, I am going to do various kind of confirmation things. If you guys can do thumbs up or head nods, those are appreciated. And I am going to be coming around helping people out. All right, so don't look at this slide yet. I am going to go and create a brand new Unity project. So I'm going to say new project. I'm using the Unity Hub here. If you're not familiar with that, it's basically a way to manage all of your Unity installs. But you guys should see something similar if you click new project. What I'm going to do is I'm just going to call this one ARCore GDC Codelab or anything similar to that. And then that's it. So I am building in 2017.3. If you guys have slightly newer version that's not 2018, that should be fine as well. And I'm just going to go ahead and create project. Sure.
I had this earlier version of Unity, and now I'm ready to work with the second one. Where do I find it?
Oh, I mean,
So
this.
it should have a different.
So depending on how you installed it, it would just blow away the older install.
It should, right?
Yeah, so this is the newest version. Yeah, this is good.
That's fine. Okay.
Yep.
So we're good to it.
Yep,
And,
just new.
Can you help me locate the path of the SDK? on
Yes,
the Mac?
yeah, so if you go ahead and hit, you'll do it through the editor, so just go ahead and create a new project right away. All right. Bam, there we are. It's saying, hey, there's a new version. That's cool. So if you guys are newer to Unity or not familiar, your layout should probably look like this. Unity has the ability to customize layouts. So I like to drag things around and kind of change this a little bit. But we should be able to kind of access and see all this stuff here. So I'm going to go ahead and swap to Dan layout. And here's what we have now. So what I'm going to do to start off is I'm going to go through and configure some settings in my project before I import the packages. So in order to do that, let me make sure I got it here. Yeah, what we're going to want to do is go to project settings. So you can go to, build settings. You can go to File, Build Settings, or Control-Shift-B or Command-Shift-B. And you'll see by default, it's going to put me on the PC, Mac, Linux standalone. We are doing ARCore, so I want to switch to the Android platform. Once I do that, I should be able to click this button, Switch Platform. If you're not able to switch platform, it'll say over here, hey, you're missing the module, do that. So again, I'm going to run through all these steps, and then I'm going to show them up on the slide so you guys understand them here. Next thing I'm going to do is I'm going to click this Player Settings button. And that's going to open up a bunch of settings over here. The first one I'm going to do is go into Other Settings and disable multi-threaded rendering. Next, I'm going to go down to my package name under Identification, and I'm going to call this, you guys can call it something unique. It needs to start with COM, and it needs to have 2 periods. So I'm going to call it COM Dan ARCore Lab .unity, something like that. Spell. There we go. And then I need to change this minimum API level to be 7.0. So that's that SDK we downloaded through there. So I've changed that now. And lastly, I need to scroll all the way down and locate XR settings at the bottom and enable ARCore. You're not going to see ARCore if you're not on the Android build platform, but you need to hit this checkbox there. So for all these steps, you can see them here. Again, switching our build platform to Android, open up the player settings, which you can click down there, disabling multi-threaded rendering, setting the package name to be something similar to that. The XXX is for you to fill in. You could also just call it that. Setting the minimum API level to be 7.0, and lastly, enabling ARCore. So if you guys can go ahead and do that now, and I can help you out. You need the path? All right, who has a MacBook with the SDK and everything located? I'm looking towards you. Seem like a confident Android developer. So the SDK or JDK? Both? So SDK is looking like users, your name, library, Android.
But it depends on where you install things. So
Yeah, but that's probably the default one. So if you guys want to try to find that, so it's going to be users, your name, library, Android. Any luck?
No, but
I'm just gonna browse it. It's just difficult to get into the library there, right?
library.
Yeah, do you have library? It should be, well, so the Java, that's where the JDK is going to be, if you wanted to try to continue to locate that.
Java virtual machines, JDK 1.8.
Yep, it's that JDK 1.8 one. Do you have a library folder that has an Android folder in it? Or is there an Android folder in there?
I haven't found one yet.
And you've opened up Android Studios and downloaded the correct SDK? Okay. You could also just try Googling Android Studio SDK. How are you guys looking? Yes. So you've installed the packages? Yes. If you install the packages, you're going to be getting errors. We have not gotten to that step yet. So I've left a little fun carrot there, full of errors for you. You guys good back here? Got everything configured? Seeing some thumbs up?
Having some trouble finding the
The SDK. So can you go to your library Android folder? Is there an Android folder in there? Oh, you're on Windows?
Yeah.
Sweet. I can show you where mine's at. So, preferences. Did you say the SDK or the JDK? All right. Mine is under users Dan app data. So you'll need to have hidden folders on in order to see that. So if you can go to your app data folder, there should be a local Android SDK. This is on the Windows side. Yep, there should be a SDK folder. I believe on Mac it has a capital S for whatever reason. On Windows it has a lowercase. This happens to be where my SDK is. What'd you say? On Mac, I am not sure. On Windows, there's this nice little bar up here that allows you to do it.
If you want to see the location where it says SDK, your folder, right mouse click on the actual folder. I'll show you.
But that's not what What's a Java virtual machine?
It's like that actual path.
It's
It's not
JDK.
Oh,
you got
so I have to find it there? And you need to look into
You have to just,
that's the location, but that's the folder structure.
Find somewhere installed.
Okay.
Maybe easier to copy paste it than you can. Just now you know.
all right, so I am going to move forward. We're going to be moving a bit slower here, and hopefully some people with some Android issues, we can help them out and get caught up. I appreciate you guys helping each other. So the next thing we're going to do is we are going to now install those packages that you downloaded earlier. So if I go to my GDC folder, so the first one is going to be Unity or ARCore Unity SDK v1.00. That is just the ARCore SDK. The way packages work with Unity Open, you can just double click those. We're going to go to the list of everything to import, and I'm going to go ahead and click import.
This is the same one that was released like a couple weeks ago, right?
Correct. It is just a packaged version from GitHub. Forgot I had the mic there. So this is going to go ahead and import, and then once this is done, then I'm going to choose the ARCore Codelab GDC Unity package. Give it a moment here. Good to go. All right, and this one is going to have some errors because I forgot to do something and I haven't updated it since yesterday. So I'm going to walk through how to get rid of those errors for the people who have done this. So you'll see that there's all these red things down here. So what we're going to do is we're going to open up the script food controller, and we're going to do a mass comment block to comment out all the code, and we'll get back to that later on in the workshop. All right, so food controller. It's going to complain about all these variables that we do not have. So what I'm going to do is type, once Visual Studios gets caught up here, I'm going to type a /*. See here, /*. All right, resharper's not working. There we go. And then I'm going to go to the very bottom here, and I'm going to type */. That has commented out everything inside the class. We do want to have the class still accessible here. So you can see I have this top curly brace and this one here at the bottom. Once I save this here and go back to Unity, once it compiles, we should be good to go. All right, so for this last step, what I did is I took my Unity project, I double-clicked on the ARCore 1.0, I double-clicked on the ARCore Codelab project, to import those into my Unity project, and then I commented out the entire food controller code inside of its class. I didn't comment out the class. The class still exists. So I simply, hit enter after this little comment, did /*, went down here, and did */. Then when we tab back to Unity, everything should be compiling and good to go. So the last small part of this scene, or this step, is we're going to delete everything from our scene. So you can see by default we're in an empty scene. We have a main camera and a directional light. Delete those. And then I'm going to locate and I can do this by typing, or I'll show you where it's at in a second, the ARCore device. So I'm going to drag this prefab in. Go down here, prefabs, the environmental light. And lastly, I'm going to create UI event system. And then I'm going to save my scene. Save scene as, we'll just call this one main scene. And you can see I've added these 3 objects. So again, they're going to be the prefabs located under the ARCore SDK, the 2 objects there. And then you go to create UI event system. So again, for this step, we are adding the ARCore 1.0 SDK. We are adding the Codelab package. We are deleting everything from our scene. We're adding the ARCore device prefab to the scene. We're adding the environmental light prefab to the scene. We're adding the event system. We're saving our scene. The hidden step that I didn't mention is commenting out the food controller code, not the class.
Looks like your laptop isn't charging.
Oh man, that's a really good call. Or wait, oh yes, it's this one. Bam, sweet.
That should have with the Visual Studio thinking a lot.
What'd you say?
That should have with the Visual Studio thinking a lot.
Ah, yeah. Good call. Yes, this laptop gets really throttled without power, unfortunately. How are things looking back here? Good to go. Sweet. Looking good. All right, how is the setup process going?
We found the SDK path. I still don't know about the JDK path. And
I can find
it
my
took
Java
one
folder.
developer.
So I think yours was in either library or users.
Yeah.
If someone else has a Mac and has the JDK path, can they just kind of call it out? That would be appreciated.
/users/your username /library. Oh, the JDK. I'm sorry. /library/Java. So instead of being in your users library, it's in your general library.
So no user?
Yeah.
Is there
Do you
some
have
folder within
iTerm?
there,
I can
or-
do it in command line much easier, and then you can just pwd copy paste. No.
Sure. Or yeah, or just we can just if you can just show it around, or I could type, or you could type something up here if you wanted. Type something on the slides.
That would be cleaner to see it on the screen.
Yeah. All right. Here, why don't you just come type it on the slides? So we'll say Mac. What's the SDK path?
So the SDK path is /users, capital U, /username, /library with a capital L, /Android capital A, /SDK all lowercase.
Like that.
S-
Right.
Zip.
All right. And for the JDK.
/library, capital L, /Java, capital J, /Java virtual machines, capitalizing each word, /JDK, 1.8.0,
Oh.
_161,
1.8.0_161.
.JDK, /content, state / home capital H.
Interesting.
Thanks so much.
Okay? And capital H on the home.
Hit the home is cut.
All right. How is that looking for people still setting up their environment? Appreciate it calling that out. Got a thumbs up. Think it's working? We'll find out in about 20 minutes. All right, so if you guys are all caught up with that, hopefully you were able to follow along with this step where we've imported the two packages, we've deleted objects in our scene, we've added some objects to our scene, and we've commented out the code there. So I'm going to go ahead and move forward. All right, so the next thing we're going to do is we're going to create an empty object. So I'm just going to go create empty. And I'm going to zero this one out. You'll notice it was in an odd spot there. And we're going to call this scene controller. Like that. And then we're going to add the component called scene controller, which does not exist right now. So you'll see it's prompting us to create a new script. So I've done that over there. Right there. And then we're going to go ahead and pop open this scene controller. And we're going to be doing this for most of our scripts. We're going to be using the ARCore namespace from Google. So you can do a using Google ARCore. This is going to give us access to certain classes and things that they've put inside there. I can even make this a little bit bigger for you guys. And then we're going to add a new void function here. So this is going to be called void quit connection errors. And again, this will be on a slide here momentarily. What we're doing here is we're basically just doing some basic error checking to see the status of our app. And we'll be calling this basically at the start of the simulation. So what we can see here is that we can do a error to see if the status of the camera permission has not been granted. ARCore uses the device's base camera. If you have not given permission to that, then we'll just error out. And to do that, we're going to call a coroutine using the Codelab utilities called toast and exit, which is going to exit the app. And we'll say something like camera permission not given. Wait 5 seconds and do that. The next error we're going to check for, we're going to do an else if to see if there was basically errors in the initialization of it. So you can see we're just doing the session status is error. One thing to note is that this is a function call, not a variable. In the slide that I'm going to show you guys in a second, it is listed without these parentheses, which will give you guys an error. So I'll highlight that again in a second. And what we're going to do down here is a similar thing where we're starting a coroutine on the utils here to toast and exit. And we'll say something like error has occurred, restart app. And again, we'll wait 5 seconds through that. All right, so again, what we've done is we're using the ARCore namespace inside our session controller, and we've creating a small function here. Inside the scene, what I've done is I've created an empty object, create empty. I've renamed it to be session controller. In order to rename, you can go to this panel up here in the inspector. If you're on Mac, you can hit enter. If you're on Windows, you can hit F2. And you can type in scene controller. And then what you do is you go ahead and add component, and you start typing scene controller. There's not going to be a component there, so it's going to say new script, and then you'll just type it in from there. And then we popped it open and added the logic. So that's what we've got here. Any questions about this? So again, empty object scene controller, creating a script called scene controller. At the top of our script, we're going to be using the ARCore namespace. That's what gives us access to things like the sessions, the status, things like these Codelab utils. I think actually those might not be under namespace, but yeah. We are going to be creating a handful of scripts in a similar fashion, so if you guys need some clarity on that, let me know, and I can walk through it again or come assist you.
Session object, where did it come from?
The session object, so basically this is going to be kind of a global session that is stored, I believe it's on the ARCore device. So there's some default session config on that device. And what you can do is you can kind of link into this as as like a singleton in a lot of your classes there. So you can do some digging in that if you would like.
It wasn't recognizing it as a, you know.
Are you using the ARCore namespace?
Yep.
Google ARCore, yeah. Huh.
But it was,
Question?
Yeah, still part of it, so.
Sure. So what we're doing is we're going to disable multi-threaded rendering. We're going to call this something different, ARCore Lab Unity, something like that. We're going to target 7.0. And at the very bottom, we're going to enable XR settings, which you've done with ARCore. Lastly, you need to go ahead and import the packages that you downloaded from Dropbox.
How to do that?
Where did you download those to?
In the download folder.
Okay, so we can go to downloads. So first one we can do is we can just double click that. And it's going to go ahead and import like that. And once this finishes, we'll go ahead and do the other one. Is everyone else good to go on this first script here? Yes, so isError is a function, not a variable, as this one alludes to. So you'll need to add 2 parentheses to the end of it here. If you go ahead and look at mine here, you can see I'm doing isError as a function call, which is incorrect on the slide. Do you guys have a question back here, or someone did? Yes, what's up? Yes, so,
computer vision controller, double define.
I'm not sure. It would say the namespace texture already contains a definition. It's basically saying that potentially you have like a duplicate script. Let's see here. Yes. So somewhere this is hidden. So there's one of them. Here's another one of them. So you have the.
Import it twice in there.
Yes, you.
Let me just delete Codelab. So then
Yeah, it looks like Codelabs.
let's import it twice somehow. Okay.
There you go. Maybe not.
Oh no, that's my problem.
All right, sweet. Yep.
I'm still in that problem. It makes no sense. So you know, like even though like I can get to let's say like session. There's nothing there. I can get to Google ARCore session. It's also like giving errors.
Huh. Let's see here.
Unless I'm missing something very simple, like please don't type in my Google ARCore.
It's looking good. Okay, sweet. Thanks for not stealing that. Huh. So can you comment that out for me? Sure. And just and tab back to Unity and see what we have? Yes. So.
Oh, that's the one. That's the one.
Yeah. That's fine. Let's see what we have there.
That should be fine now. But still, the other one, I can figure out later. You know.
Yeah, I'm not sure what's happening with the like autocomplete of the ID there, but all right, we're gonna move on in just 1 minute. I lost my water bottle. Is this my water bottle?
Not mine.
It's not yours. Is this your water bottle? It's probably my water bottle.
How do I add whatever?
Yes, perfect. You deleted everything in the scene, so we can go to Google ARCore prefabs. We're gonna put the ARCore device, the environmental light, create a UI event system, and then we're going to create, a new object. We're going to call that session controller. We're going to add component session controller as a new script, and then we're going to go ahead and pop that open and type in all the stuff that I've typed in here.
So doing things in the wrong text editor.
Ah,
So, like, do I need all that also? Or?
so yep, we're going to be interfacing with that in a second. For this, you'll be using Google ARCore, and then we're going to create another function down here, which we're calling, quit on connection errors, like that, and filling in the associated. All right, how are you looking over here?
Yeah, just on the last line.
Perfect. All right, I am going to tab back and continue on. I will be able to pull up the script momentarily. We're going to just kind of continue to add to it. So next thing we're going to do is we're actually just going to call this in the start function. So show quit on connection errors, do it like that. And I can you guys still read it like that? Is that okay? Yeah? Sweet. So I've called quit on connection errors in the start, and now I'm going to type in some code in the update function, which is basically kind of checking if it's if the ARCore is tracking and setting a timeout on the screen. So we can do an if session status. If it's not equal to session status.tracking, then we're going to say make an integer lost tracking sleep timeout equals 15, like that, and then we're going to say screen dot sleep timeout equals what we just declared there, and then we're just going to return. So basically, if it's tracking, we're just going to kind of continually do this over and over and try to put it to sleep. And if it's not, so if it is tracking, we're going to say screen dot sleep timeout equals sleep timeout dot never sleep. All right, so for this step, we've added the quit on connection errors to the start function. You have a question?
You've got your int is sleep timeout.
Yep, that's my buddy Tim. Just kidding. Thanks for the call out there. Nice thing about coding is once you misspell it once, you can just misspell it everywhere. But it's a good thing there. So yeah, this is what we're going to doing this quit on connection errors, and then basically just checking status to see if it's tracking. You'll notice with this session tracking here, this is where you can actually link into other things like not tracking or lost tracking. So if you were to kind of inform your users, hey, you're moving around too much, tracking is lost, you could also kind of reset certain functionality in your app, linking into this session status here. But again, for this one, we're going to say if it's not equal to tracking. And if someone needed to see that, I'm just going to kind of leave all this script up on. This is basically the next step here. Are you all caught up there? Sweet. All right. And if everyone wants to work ahead, the next step is to build your application. So that is to actually test if you've gotten the Android thing really set up and if all the settings are appropriate from there. You can go and build your application to the device. What it'll do is it'll launch the device. It'll prompt you about camera permissions. If you allow those, you should just see a camera. So there's no functionality. This is kind of the base ARCore taking advantage of your phone's camera and quitting if there's any errors. So if you're not familiar with the build process, I'm just going to tab to that real quick. You can go into, you can hit Command-Shift-B or Control-Shift-B. And I'm going to delete this duplicate scene controller here in a moment, like that. I'm going to hit Add Open Scene. If this is the open scene you have, it'll do it automatically. But this is kind of a helpful organization. And then you can plug in your phone, unlock it, and hit Build and Run. Now, if your phone is not recognized by your computer, the developer options may not have been enabled. And in order to do that, you need to go to, I believe it's Setting, something about Build Options. Click on the build number of your phone 7 times, which will then unlock a developer options. Go into developer options and find USB debugging. And I can walk you through all that. But again, this next step is going to be build and run. So again, just save your scene, add it to the build settings, build and run it on your device. And if you guys wanted to see the code, there it is. So I want to see a lot of camera feeds with nothing else happening and see some successful builds. There we go. Perfect. We have yes. About. Bottom.
Oh, there it was. Okay.
And then scroll down to the bottom of that. Tap the build number. So it's under About Phone. Oh, keep going. There you go. You are now a developer. So hit back.
Yep.
Now you have developer options.
Sweet. Thank you. Are there any options we need in the developer options?
Yes, USB debugging. It's under like About Phone and then System, or is it System? Yeah, System, About Phone. Tap that 7 times. Keep going, keep going. Oh, it says you're already a developer.
Oh, okay.
No need. So, but once you're a developer, you need to go into developer options. Whoop.
USB debugging.
Yeah, where's that? Oh, there it is. It's already on. Yeah, so you should be good. You should be able to hit build and run. Yeah, just name it whatever you want. Yep.
I got this on some phones, but it's basically not seeing the phone.
Yes, so Android.
It's in the developer mode already.
Okay, let's check it out here. Developer options. USB debugging has not been enabled. Now it'll be able to completely be recognized. Hello, it's all right. Welcome to the Bay. Yes, so, all right. You're getting excited about errors that you have not encountered. So what we want to do here is, that's, you know what? You should send me an email about this because that has the wrong name. So if we go to player settings, look at our other settings, we are targeting still Jelly Bean.
Oh, I see.
Jelly Bean is old. We're now eating nougats. So we need to make sure that we are on 7.0 for the target because ARCore is basically supported on 7.0, not on earlier ones. What's up?
I get a build error too. It failed. It says error building player because script says compile errors.
Yep, sweet. I mean, you know, that's all right.
Okay. I don't have
So go ahead and hit the clear button. I could scale this entire table. Let's see how this works. Let's do this. All right. No problem. All right, so session status type, but a variable was suspected. So if we go ahead and open this, you are doing session status. It is session dot status.
Uh-huh.
So you are
So
not
that
compiling.
ended here, but not here.
Correct. Those are different things.
Okay, okay.
Very confusing. You can blame that one on Google.
Subtle difference.
Now when we, there we go. So now we're all compiling. Now we go in here. Now we hit build and run. Now we test it out. Go ahead and unlock it, and let's see a camera feed. Yep. How's it looking? Good? Camera feed? Perfect. I see a amazing Android developer through the phone.
Test device?
Yes. Please don't steal it. This is an available spot. It's my shortcut to the back, but you can go ahead and take it. You have missed a lot. Here we go.
I'm not able to get to my developer settings.
Please don't. Okay, so I will show you the. Here we go. So, the route to becoming a developer in Google is tap this 7 times.
They ask, go to, let's say, something like
Interesting. Let's
I'm
see
gonna use
here.
The device you gave me. That's a little twisted one.
What device is this? It's Pixel?
This is one, yeah.
but,
System, about phone.
console here, so you have these two.
Weird.
You can use
Right?
look for the foot controller.
Whoops.
Foot controller. So click on that. So you just
Why is that happening?
I don't know.
I fixed it previously. I thought there's something that I don't know.
I mean, I would just,
Restart it?
no, I would just Google Pixel 1 developer options.
they are gone. This is a warning, just this I have never used.
Good to go? Yes, around the corner. Got a question in the back?
Yeah, won't build.
Won't build. All right, let's check it out. What are the errors that we get when we're trying to build?
Ironically.
Build failure. Unable to list target platforms. Make sure the Android SDK path is correct.
Which I have confirmed in terminal.
Okay. Someone was running into a similar error
Oh, that's right.
yesterday.
It was
Oh, yes, there's a yes. All right. Question back here. Same error as what?
with the SDK path.
SDK path? Let's go ahead and check your path under preferences. External tools. All right, let's see. That's looking good there. It says unable to list. There's basically someone else ran into this problem yesterday. I've run into it as well. What is the, you can basically Google that error, and there's like this small little package that you just install. But the Mac one is below that, right? That's the Windows one. Scroll down. Just keep scrolling, or. Bam. All right. So there's some, what's the name of that file? So there's like a tools revision that you can download. If you Google that, there should be like a Unity help answer. I've run into that as well. How's it looking up here? Good? Sweet. How's it looking?
It's building now.
Oh, okay.
It's
Building.
yeah.
Perfect. How's it going here?
I thought it was disconnected from the cable and just tried once, and that doesn't work.
It's only just a camera right
This one doesn't work either?
No, I've not tried it
got
yet.
anything, so you just grab the camera and show me nothing.
I don't know what's wrong with this.
All right, this one is set up for USB debugging, so we can use that for now. Please don't steal it. All right. So we had some people. How you feeling? Got some thumbs up. you're able to basically, again, this is kind of the core functionality or core kind of configuration for building an ARCore app. We haven't added any functionality, we haven't added plane finding, we haven't added touches, and that's what we're going to be doing next. So for this next step, what we're going to do is we're going to go into our scene controller, and we're going to add a component called global scalable. We're going to configure this component to handle scale input. So you can see here I've added this component to the scene controller. And I'll talk about this a little bit later, but basically this allows you to pinch to zoom in order to scale content that is on the plane. Kind of a helpful script that you can use outside of this. The next thing we're going to do is we're going to go ahead and start creating our plane. So in order to do that, we're going to go to Create 3D Object Plane. This is the plane primitive inside of Unity. And we are going to change its material from the default material, which it has listed here, to the plane renderer, or plane grid. There we go. You'll notice it looks a little bit transparent there. There is a texture if you zoom in on it. After we've done that, we're going to add 2 components to the plane. This took me longer than I'd like to admit to debug this, but we need to make sure we add both components. So the first one is the plane renderer. The second one is the tracked plane controller. All right, so for this next step, what we're doing is we're going to our scene controller. We're adding a global scalable component. We're adjusting its handle scale input to be checked and its adjust scale to not be checked. We're creating a 3D plane primitive by going create 3D object plane. Then we are setting the material on this plane to be plane grid, and we are adding the plane renderer as well as the plane controller. And finally, one step I didn't do before, I'm going to call this tracked plane display. So I've changed its name. So there's the steps for that. So this is kind of going through and creating the default planes that are going to be rendered in Unity. Yep. Probably because it was maybe using one of those folders we deleted. Is there another plane grid? There's not.
What I can do is re-import the Google ARCore thing. Interesting.
Yep, there's just kind of unlinked there. So the global scale one, this isn't 100% necessary, but it'll be kind of cool when we get it working in the future. This is necessary. Probably should have maybe color-coded these, but we add the script plane renderer, and then add the script tracked plane controller. Global scale allows you to pinch to zoom, and it basically scales up the food and snake on our plane. All right, so again, we're basically configuring a plane from a plane primitive here, and that's what we're going to be using once we start adding additional code that basically tells this plane what to do. So just to show you, yep, question?
Yeah. Because my thing just crashed, so does that mean that it kind of wiped out everything, or?
Bam. You had saved it as a scene here called ARCore Workshop.
Okay.
Yeah, we can just add the global scalable there and then create the plane prefab, plane primitive. How's it going?
We met at Oculus Connect,
Hmm?
by the way. Stack, the post-processing stack. I'll show you the results.
Remind me, if you find me throughout the conference, my buddy made some post-processing stickers of the little gizmo if you want those. All right, I'm going to tab back and show my version of the editor here, which has the object. I've renamed it to tracked plane display. And you can see I've added two components, plane renderer and tracked plane controller. All right, now what we're going to do is we're going to go ahead and move on, and we're going to open up the tracked plane controller. So you might have noticed that there's a lot of code that's just commented out. And what we're going to do first is we're going to add a awake function. So if you're familiar with Unity, when you create classes, they have the start function and the update function. The awake function is called before the start function. This is actually another huge gotcha that took me many hours to debug because I put this call in the start function, which was not happening between two kind of function calls later on in the script. So for this one, this is where I get my reference to the plane renderer. Fairly basic stuff, but the way it's lined up elsewhere in code is it needs to be in the awake function. So you can see we have a variable up here called plane renderer. I've created a awake function, so it's just void awake, and added it in there. And then what I'm going to do is I'm actually going to go and uncomment this stuff like that. And now I'm going to add a new function, and we're going to call this one needs to be public. And we're going to call it set tracked plane. Inside this one, we're going to basically say the tracked plane that we're calling this from is equal to the plane that we're passing in. Then we're going to get the polygon boundaries, which populates a list of vector 3s. I'll show another kind of clever use case of this similar type of callback here. But basically, this allows us to get all vertices on the plane by calling that get boundary polygon. And then we're going to initialize its renderer. This allows it to choose a random color from a color array, as well as a random location. Let me zoom down a little bit there. And then lastly, we're going to update it with the current tracked plane. And for this, we're going to pass in the tracked plane center pose, which is basically the center of the plane, and the polygon vertices here. So again, for this step, we have added an awake function at the top. We've uncommented this update by deleting the kind of objects that look like that. And we go down to the bottom, and we've added this set tracked plane controller. So something like that. All right, any questions? Yep.
Technically, about your compiler, I see you have this tool that's giving you references.
Yeah, you're talking about like the autocomplete and stuff like that?
Yeah, I've never seen that. I'm curious what tool that is. Yeah, like chart changes, alters.
Oh, this thing? This is ReSharper. So it's basically a product by JetBrains that allows it to go in. It also does some cool stuff, like if I open up, let's see it compile here. If I open up this plane renderer, it colors these colors, which is kind of convenient. Yes, very cool. These ones are fairly basic, but there's also a more intricate one here. Let's see here, plane Maybe this one? Yeah, see, look at these. These are random colors, but it gets the exact color for those as well. So very helpful. Yeah, it's ReSharper. It also gives you some suggestions on restructuring code and things like that. And then this, I believe, is somehow linked into like Git. Yeah. Yeah. All right. Are people good to go on that step? Good to go. Got a thumbs up. Let me respond to a message real quick. All right, I'm going to go ahead and move on here. Sure. Pictures away. I will say this is available online, and you can also email me for the slides after, if you so choose. Be happy to provide those. All right, moving on. What we're going to do is we're going to create a prefab. A prefab in Unity is basically an object that lives in the project folder that you can then reference through scripts. The way we're going to utilize this tracked plane prefab is that we're going to spawn it as we recognize planes from the ARCore API and then kind of fill it out based on that. If we were using the one in the scene, we would spawn that one and then potentially delete that when it kind of lost that plane and we weren't looking at it, and then we wouldn't know which one to spawn. So to do that, yes, and the reason it's doing that is because if you go to your ARCore device, you'll notice that there is a default session config. This is a scriptable object that basically holds 3 variables. It says match camera frame rate, enable plane finding, and enable light estimation. So plane finding is enabled and happening, but there's nothing there to visualize it. Very good question. So what we're doing is we're creating this plane to visualize it. In order to make this a prefab, I'm going to drag it from my scene into my project over here. And you'll notice in the project, it's going to turn blue, or in the scene there. That means it's a prefab. I highly suggest making sure this is blue before doing this next step, which is going to be deleting it from the scene. Next, we're going to go into our scene controller, not our tracked plane controller, our scene controller, and we're going to add a public reference to that. So we're going to say public game object tracked plane prefab, like that. And then we're going to save this scene. We're going to hop back to Unity. We're going to wait for it to compile. Oh, wait. Oh, wow, I can't even see that. So I was going to show you guys, if you're not aware, there's a little thing in the bottom right-hand corner that shows Unity compiling. But once it's compiled, I can go to my scene controller. You'll see that it now has a public reference called track plane prefab, and we're going to drag that like that. And remember, this is the prefab version. We don't have a version in the scene anymore, and we can go ahead and save our scene. So for this next step, drag the plane prefab display into your project to make it a prefab. Delete it from the scene. Add the public game object reference to the tracked plane on the scene controller. So public game object, and then save it. Tab back to Unity and associate that prefab. Yep.
I'm still the place where you said changing the material to render.
Yep, so you see there's a little drop down that says materials, and your Unity crashed. Is it this one?
Yeah, that one.
I didn't do this step before this. To be from the scene.
Don't worry about that. So over here in the hierarchy, the plane
Why it's crashing. It does that a couple times already.
Yeah, I've seen that.
Okay, and now if you click and drag it over.
What operating system are you running?
This is a Mac.
I meant, yeah, I was gonna check.
Change it or anything.
Yeah.
You mean like which OS is on?
Yeah, I just meant which version. Oh, you know, let me just check this. Yeah, I don't see anything. Sometimes, like if it's too small or something, but that is the way. You can also if you find that in the scene, you can just drag it on top of it instead of going through the interface there. Let's see if we can do that without crashing. So I can search down here, plane grid, and then I can just go like that. And now it has the plane grid. So then for this, we need to add the plane render and plane controller. Right? And then we need to make this a prefab by doing that. All right. People got some plane prefabs? Hopefully? Throwing up the horns? Sure.
The cannot get revision from server, is that just like an outage? Like it would
Yeah, you're talking about Codelab?
yeah, just the cannot get revision from server.
Yeah, I'm not sure on that one. Yeah, that's what I would imagine. All right. We're going to try to speed up a little bit. Yeah, so we have a tracked plane prefab. We have a reference to the scene controller. Now let's start processing those planes, which basically take the SDK information and put it on there. How is my friend playing Super Mario Galaxy on Steam? Let's go ahead and close that out. Some fishy stuff going on. All right, so we're going to create a process planes function. So we're going to say void process planes. And in here, we're going to create a list of tracked planes. Tracked plane. And we're going to call that planes. Make it a new list. We're going to say session get trackables planes. And then we're going to basically have a query filter here, which we are going to call new, the new planes. So basically, this get trackables is convenient for kind of getting any tracked object that you have from the SDK. This could be oriented feature points or feature points in general. Let me zoom that up for you guys. And we are using so basically we've created a new list we call get trackables, which populates this list with all of the new planes. This is an important differentiator here. If you have all, it basically just continually spawns planes on top. Creates kind of a cool rainbow plane before killing your device frame rate and crashing. But we want just the new planes. And once we've done that, we're going to loop through them with a normal for loop here. And each of them, we're going to basically spawn a new plane if we've detected a new one here. And we're going to do that based on the reference to the tracked plane prefab that we've linked to the script. And we're just going to spawn these at the very kind of origin or center. And then the SDK is going to kind of take over from there. We are creating them as a child of the scene object. And then what we do is we get our component for the tracked plane controller. And we call that set tracked planes, passing in the planes that we're looping through, or the plane that we're looping through. And the last thing we're going to do is we're going to take this function that we just wrote, and we're going to make it happen every frame by copying it into the update function here at the very bottom. So again, this is again kind of a core feature of what ARCore is doing, or maybe able to kind of take advantage of here, is we're just getting a trackables, which is just populating this list here, using the query filter for new. So you can see that there is also, we have all or updated, but for this one, this is how we're just spawning those objects, so we just want the new ones. So for this step, it's looking something like that. You can see there's some comments there about it, but we're just doing this down here. Is it easier for you guys to read this or on the on my Visual Studios? Hmm? Does anyone have a preference? Do they like the slides or my Visual Studios? Visual Studio?
On this one, you put void process planes, and on the other, on the screenshot, it said view process new planes.
Yes. See? Yeah. Same thing. Just make sure you name it the same in both spots.
So what the rainbow effect that you're talking about is that trackable query filter dot new. So if I don't get what is trackable query, is that right? And what is dot new versus what are the other options?
Yeah. So the other options are all and updated. So basically what I'm saying is, hey, I've created a new list over here. It doesn't have anything in it yet. That's what we're doing with this line here. Then I'm saying, hey, session, which is the ARCore session, give me the trackables, which is some sort of tracked object I need to pass in. I'm saying, hey, the trackables is this list of planes. So it's saying, hey, give me a list of something. And then of that list of tracked objects, give me all of the new ones. If I do all of them, I'm just going to get every single plane. But the way that this for loop is happening is that this is looping through everything that this list has been populated with. So if we have trackable query filter all, then we're going to say, hey, give me all the planes that you have, and then spawn another plane and initialize it to exactly that. So if we have all instead of new, it's going to say, hey, there's a tracked plane, and now we filled that list up with that same tracked plane again, but this is querying or looping through all those planes again. So it's just going to keep spawning on top of that. Since we're doing new, we're saying, oh, we already have a tracked plane here. When I do this query, if I'm filtering for new, this list is not going to be populated with this plane anymore because it's only looking for new planes that are found. Does that kind of make sense? Sweet.
What did you call process new planes?
In the update function at the bottom. So right here, under our little timeout.
So at this point, it should show planes, right? Because the process planes are assigned.
Correct. This now is, the next step here is to just build and run. And you now should be seeing some rainbow planes. I see some head shaking back here. All right, let's see here. So again, these tables are not super great for finding it. There we go. So we actually found a plane. So I recommend maybe checking your laptop or your neighbor's laptop or the ground behind you. So you can see that we've actually found another plane, and it randomly colors them based on what you find. And you can see we can kind of expand it out from there.
Thank you.
So if you guys want to build it, should be seeing some rainbow planes, and I will go back down to my process planes function. Yep.
Try to build.
Yep. So can you show me your device, or can I have it? So it looks like you're basically doing a build to run, which is trying to push to the device automatically.
Yeah.
In order to do that, you need to have USB debugging settings enabled. So we're going to go to Settings, System, Developer Options. Oh, it is. So let's try here. Go ahead and hit retry. Then there's a little prompt here. You have to authorize it, and now I think it's going through.
All right.
Basically, I mean, sometimes Android is just a little finicky. What you can always do to check is if you go to your normal folder here, this should now, if you go to, is this your computer? No, this one.
Yeah.
You should be able to see that there. That's, oh wait, is that this?
No.
Huh.
No, it's not that one.
Here we go. Allow. What's can you tab back into Unity? Is it still just building? Yeah, it's freezing out. So it usually should show up inside there. Okay, let's try this. So you can hit cancel. So again, it was kind of something with, I think it might be something with your connection. I would maybe try a different USB port. I can give you a different USB-C if you want. Here, why don't I try to give you a different cable? If not, you can build it and side load it, but again, you need it to show up there to side load it. Let me try giving you a different cable. Yep.
This is weird. I do have the plane to get set track to plane.
Yep.
It auto-completes to that. I know it's right here. But yet, when I try to build and run, I get the error message.
So, yeah, you're getting an error down here. So let's check it here. So yeah, it's not compiling. So it's saying tracked plane controller. So you've called it set tracked plane. If we go to your tracked plane controller,
It auto-completes to set track plane, so. And it also builds here, which is really strange.
It is strange. Let's just try. Can we quit out of, is this it down here?
Yeah.
Sometimes I've had some issues where it like says it's saved and it's not saved.
It might well be the case.
Let me get these guys a new cable real quick. Here, I'll swap out that. Did you guys any luck with it?
We try the development build now, if it will never help.
Nah. Here, try this cable, and then I'll swap out for the old one. Yeah, I mean, for the build and run, it needs to be. Oh wait, am I grabbing the wrong thing? Are you trying to debug it? Can I see? Oh, you haven't saved the scene? Or yeah, I was just saying. Whoops.
I just kept it there for reference.
Oh, okay.
It was, for some reason when I was creating the script, it was naming it as nothing selected. The script name was called nothing selected. And it was a file of, I don't know.
Maybe that's a reserved word.
Yeah.
So do you see it in your computer now?
Oh, cool. Yeah.
No.
Still no.
Let me try I'll swap out.
Okay.
All right, let's see this here.
Yep. I don't think so, no. I don't.
So that to me is a missing curly brace or something. Yes, so you have a extra curly brace.
Oh
Bam.
my gosh.
There you go.
Thank you. All right, well.
Here, let me swap out pixels for you.
Right.
Nice. Yeah, that's not right. One sec. And again, just to mention, just needs to turn on stuff. The optimal way to kind of find planes is actually kind of moving your device back and forth. So, so this is missing a texture. Bam. When it recompiled, I had to do that. How's it looking for you?
You know that was the texture. Oh, because you see it right there. Okay.
supposed to happen?
So what's supposed to happen is you're supposed to find planes. Let's see here. Let's look at your stuff. All right, I'm not seeing any planes. It does take a little bit to initialize sometimes, and again, you want to be looking for things that have high feature points and high contrast, not necessarily your thing. So let's go ahead, and first thing I'm going to check is your Unity scene. So we have the scene controller. It's referencing our tracked plane display. In here we got that, plane render and that. Yeah, that is looking good. And you saw, I mean, I guess everything should be fine because you've built it before, right?
Yeah. The camera's coming up.
All right, let's try launching it one more time here. And I'm just going to walk around with it and see if... Yes, I will say with something like that, there is some special stuff going on in the shader. So you need to make a small modification to that that shader. But yes, you can just replace it kind of with grids with something else. To get full transparency, you need to make that adjustment that I'm talking about, if that makes sense. What have you been calling it? Is it ARCore 10 or ARCore?
ARCore, I think.
Just go in your ARCore. So you're expected to see rainbow planes. Yeah, so it's like planes and then they start kind of becoming rainbows here. Yeah, I'm really not seeing anything on this one.
I think I missed a setting or something because it's not connecting to my phone. It's saying that's not finding it.
Okay, let's. Do you have USB debugging on? Let's check it here. So we're in developer options. You have USB debugging. I'm just gonna close this. And can you go into your just normal Windows Windows?
Supposed to find like just my
Yep, and then go to this PC.
Too shiny.
Too shiny. Okay.
Okay.
Do we see the phone there?
No, but yours found the phone.
So you need to be able to see the phone in here. So what I'm gonna do, I'm gonna swap out this.
But my cables.
Yeah, because it looks like, is this small to see? Yeah. Let me give you a loaner one of those. All right, here we go. Here's a loaner here. Any luck back there? Yep, it was just the phone was being weird. Good stuff, cool. Do you guys see planes? Still nothing over here? Let's check it one more time. So we have our default session config. Looking fine. Event system.
There's supposed to be something in the...
You're not calling process planes inside the update function. So you need to call it right there.
One thing, like, why don't I have to restart the app to change the color? Where is the color?
Yes, so the color is happening in this initialize.
Okay.
So that's hotkey that I was about to do is probably not going to work. So if we go to plane render, I'm just going to do this for now. These are the colors, so it randomly chooses one of these colors and initialize
And that's
a random
executed
range between those.
In the update function, so that's why it's happening.
That's when it's initializing. I'll be back in a second. So let's check what we. So I will say it's it's not. It can be a little tricky depending on what you're looking at here. All right, let's go ahead and see your scene set up. I'm really not seeing anything. Okay. So we do not want this to be in the scene anymore. And what we want to be referencing is the prefab version of that.
Okay.
So you see I just deleted it. We need to link it up right there.
Okay.
Now go ahead and save and run. All right. All right, I'm going to go ahead and move forward. We're getting a little tight on time, but we have at least some rainbow planes, which is, again, some of the core functionality there. So the next thing we're going to do is handle touch input. So in order to do that, we're going to go in the scene controller, and we're going to create a public reference to the camera. We're going to call this first person camera. And once we do that, we're going to create a new function down here, similar to process planes, but we're going to call it process touches. All right, and we're going to do some basic kind of Unity touch input here for the first part. So if the touch count is not equal to 1, or the touch input get touches, whoop. We're going to do input dot get touch for the initial one. The parentheses get a little weird here, so keep that in mind. Not yet. But we do want this, I think it's like this for the phase. If the phase is not equal to the touch phase begin, then we're basically just going to return here. So we're basically saying, hey, if there's like too many touches or there's no touches, then just return. And if the touch phase is outside of begin, so if it's like not right when it happened, then return as well and kind of ignore it. But if we get through those, we're going to be basically creating a ARCore specific raycast, okay? And for this, we use something called a trackable hit, not a trackable. And then we're able to cast rays specific to the frame. First, we want to make a trackable hit flags, which is kind of like a layers, if you're familiar with normal raycasting in Unity. And we'll call this one raycast filter. And then we're going to do trackable hits for planes within bounds or trackable hit flags for plane within polygon. Yeah. So if you were to create an app where you only want to attach things to the feature points, or only want to attach things to planes, or only want to attach things to kind of the center of planes, this is where you could potentially set up some flags for what you're ray casting against. And this ray casting is going to be from the device into the world. And to do that, we're going to do frame raycast. So again, this is set up very much like the normal Unity raycast, like this. And then we're just going to pass in our filter, and we're going to out our hit. So if you're familiar with raycasting in Unity, you know, almost identical kind of documentation or things here. And then what we're going to do is, if we do find it, then we're going to call set selected plane, which has not been created yet. Set plane, and we're just going to call the hit.trackable as and cast it to a tracked plane. And to complete this, we're just going to do a void set selected plane, have a trackable plane. Whoops, did I just delete everything? Sweet. Have a trackable plane, something like that. Tracked plane. All right.
Is this like hit test result in ARCore?
Yes. Yeah, this is, so basically both AR SDKs have their own custom kind of ray casting system where you're taking the device, you're saying, hey, I touched here, raycast into the world. And the reason for that, one of it is being able to query against things like feature points. You know, feature points are small little points on an object, and if you want to kind of raycast against that, you probably actually want something like a sphere cast or like a larger thing than like an individual point to be able to really hit a feature point. and it also has some optimizations for kind of looping through those and centralizing it, what it's casting against. And then you get these filters or flags that you can specify exactly what you want. So if you're creating an app where you're like putting things on walls, right now you'd have to be using oriented feature points. And so to restrict it from putting things on the floor, you'd create a query with this without the planes. Question?
We don't have to go through the array when we do layout.
Right. Yep.
Why have the touch.equals rather than saying input.getTouch? Like, why have that intermediate step of assigning it in the parentheses?
So we can make sure. Are we using it later? Yeah. Yes, because we're using it later. You see, that's where the touch assignment is happening. So we declare it. We're using the touch position there. So we just inline assign it and then use it down there. Yeah, I agree. Makes it a little complicated. All right, and the last step for this is to make sure that we're processing these touches inside the update function, very similar to what we were doing with the planes there. So I'm going to scroll up, find this process planes, and call process touches, just like that. All right. Now I'm going to run to the bathroom very quickly. My mic does not turn off, so can you guys please mute me in the back?
Actually, can you take it off?
I'll take it off. Perfect. Testing. Testing. Yep. Yep. Yes. This is a brand new function I created right underneath it that I conveniently hid as I left the room. There's a last function here that we're calling inside this raycast. All right, so we are running a little bit tight on time. We have a half an hour. We do have to get out of here at 3:30. So I'm going to jump ahead a little bit, jump to one of the best jokes in this whole presentation, and we're going to skip some of the functionality. If you guys do want to go back and do it, it is freely available online. I can send you guys slides. I apologize about the speed at which we've been going. This is kind of, again, one of the more code-heavy things that we've been working on. So we have the process touches. This is basically allows us to, what this is going to do in the future is we're going to touch the device. It's going to say, where do we touch the device? You know, at the X and Y position, cast into the world, find the plane that we cast on, and then set objects relative to that plane. So the way that this application works is that all of it kind of takes place and exists on a single plane. So we're not jumping between planes, we're not putting things randomly on planes. We're saying, touch on the device, find a plane, put everything on there, and then centralize our functionality and kind of game on that plane. So what we're going to do here is we are going to jump to slide number 30. Snakes on a plane. All right, so the game here is that you're basically kind of putting a little snake on the plane, and he's going to be able to move around and drag from here. So I am skipping ahead. I believe we can skip over the functionality. Hopefully we won't run into any errors. But I'm going to now walk through creating your snake. So we're back in our main scene here, and we're going to start by creating an empty object. We're going to call this guy snake, and we're going to add 2 classes to him. The first one is slithering, like the way snakes move. And the second one is snake controller. I'm going to go ahead and zero him out, like this. And the next thing I'm going to do is I'm going to hop in the snake controller here and add a whole bunch of variables. So we're going to do a tracked plane, which we'll call tracked plane. We're going to do a public snake head prefab, which is going to be a game object, like that. We're going to do a private snake instance, and then we're going to do 3 more. We're going to do a public game object for the pointer, which he's going to follow, and a public camera, which is the first-person camera, and lastly, a public float for speed, which will initialize to 20. All right, and once we do all that, we should be able to uncomment all this. I named this differently. So I'm gonna make sure you'll see that I had some errors that were listed there through that. So again, for this quick step, once this compiles, we have created an empty game object. We're calling it snake. We attach the 2 components of slithering and snake controller. Those are already in the project that I've given you. And then we hopped into snake controller and we added a bunch of variable names and then uncommented the block there. Some of these prefab names do need to be exactly as I typed them here because they are referenced a little bit later in the project. Is it getting hot in here? Yes? All right. So I'm going to potentially turn this on, but it might mess up with, okay. Let's do cool. Right, there's 2 in here. Yeah, so I just named it snake. You can name it whatever you want in the scene. That's not super important. But you do need to add the 2 components of snake controller and slithering. And then we've added these 6 variables. So these guys through there. And just for your own sake, the part we're skipping over is a scoreboard. So there's kind of a scoreboard that sits there. It finds the center of the plane, puts itself a little bit higher, and keeps track of all the score. Instead, we're going to skip to the fun stuff, which is the snake on the plane. And it's going to basically, I think we'll be able to get to spawning kind of food and other objects that it can go and consume. All right, so after we've done this, we've added the variables, we've uncommented this block. You can see if I jump back to Unity, I'm not getting any compilation errors because of the naming of the variables. Now what we're going to do is we're going to fill in all of these public variables that we've made here. So for slithering, we want to grab the body prefab, which is going to be under Codelab prefab. So you can see there's a snake body prefab. So I'm going to fill that in there. I'm going to grab the snake head prefab, fill that in there. The pointer is going to be this gaze pointer, and I need to not fill that in there yet. I need to first drop it in the scene, then go back to my snake and fill that in. And lastly, the first-person camera, which is hidden under the ARCore device. So again, snake body prefab for the body prefab on slithering, snake head prefab for snake head prefab. The pointer is going to be this gaze pointer object, but first I'm pulling it into the scene. And again, I'm under Codelab prefabs up here. Depending on how your project is set up, you might see something like this, and you also might see something like this. So there is a helpful but hidden button inside Unity at this very bottom that basically adjusts the size of the icons. Personally, I don't like seeing them, I like reading them. So I kind of drag it all the way here. It makes it much easier to search through. I also kind of prefer the one column layout, which is more of the classical Unity, and you can see that we have that there. So one more time, body prefab and body prefab, snake head prefab and snake head prefab. Gaze pointer has been dragged into the scene, and I'm referencing the one in that. And then the first person camera is just the camera in there. Yep.
We do the same thing in the scene controller. You have the camera.
Yes, I did, and yes, you should. That is a great call out. Probably one of the steps I skipped over. So, scene controller has a first-person camera reference. We need to go inside there and drag in the first-person camera. I believe that's what makes the gaze thing look around. So, thank you for catching that. All right. So I can go back there. You guys can look at those. All right, so now what we're going to do is we're going to hop back to the snake controller here, and we're going to create a function called setPlane. So, and this one needs to be public, so we're going to call it public void setPlane. We're going to take in a tracked plane, and we're going to assign it to this one's tracked plane variable, and then we're going to call spawn snake. All right, so I've just created a public void function inside the snake controller here. All right, and then in order to hook this up, we need to go back in the scene controller. Again, this is just a quick function that I've added in the snake controller. We need to go back in the scene controller, and now we're going to hold a public reference to the snake. So we're going to call public snake, whoop, if I can spell public, snake controller, snake, and we're going to call, or we'll call this snake controller, doesn't really matter. We're going to then go down here in this set plane function that I was talking about earlier, and this is where we're going to set the snake controller's plane using the plane that we're passing into the function here. So again, for this last step, we've gone in our snake controller. We've added this set plane function. Does need to be public, so it can be accessed from another script. We are simply setting our own private tracked plane variable to be the plane we're passing in, and we're calling spawn snake. That's what's going to be instantiating its head. Inside the scene controller, we now have a public reference to the snake controller, and down in this function that was empty, we are calling the set plane function on the snake controller itself. So again, this is what is happening when we touch the screen and we find a plane. We're saying, hey snake, set your plane, spawn your head, start doing stuff. All right. Everybody good with those steps? Getting there? All right, so there is a few more steps that there's basically 3 more steps or 4 more steps that we're going to go through, and then I think we're going to have 10 minutes to hopefully debug, catch people up, as well as random Q&A. I will be able to give you more information. I can email you the slides, whatever. I have business cards to pass out and things like that. So moving forward, we are going to go to our scene object or scene controller and add a script called food controller. You guys might remember this one making an appearance from the very beginning. And we can go ahead and open this up. Again, we've applied it to the scene controller, and now we're going to add some public variables here that were causing errors earlier. So we're going to do a tracked plane. We're going to do a instance, a game object, so food instance. We're going to do a float called food age, because all food expires. We're going to do a read-only float, which we're going to call max age to be 10. And then we're going to create a public game object array. And this is going to hold the references to the food models that we have. Whoops. All right. And once I do this, I should be able to uncomment all this. I'm just going to do this real quick and scroll back up. And it looks like we're compiling fine there. So again, I've added 5 variables here. 4 of them are private, 1's public. And this is a script that I want to talk about. So what's happening here is, in a lot of these scripts, if you notice, if you dive into them, we're going to be failing early. So, in update, if the track plane's not there, we're just going to be returning if it's equal to null, rather. If it's not equal to tracking, again, kind of fail early inside the update. Here, this is something called track plane subsummed by. That's basically, if you notice ARCore, if you have a plane that's on the ground over here, I detect a plane on the ground over here. As I kind of merge them, or as they find each other, one gets subsummed by or kind of overlapped by another. What it does is going to destroy one of those and then just merge them together. So one of them is going to take over. If that happens, then it's just updating what the track plane reference is. And basically what we're doing here is if it's not equal to null, or if it is equal to null or it's not active, then we're going to spawn one. So we're just kind of spawning an individual object each time. This is just kind of lowering its age, things like that, destroying if it expires. But here is the really interesting thing that I want to make note of. And this is something that you can totally use in other applications. This is kind of some cool kind of built-in APIs inside ARCore that isn't really talked about that much, but is cool to take advantage of. So what we have here is we're just creating, grabbing a random food model from our array. Then we're creating a list of vector 3s, which we're just calling vertices. We're, initializing that list. And then we're using this get boundary polygon to populate that list of vertices. So, we're finding our tracked plane, which has been set by after we kind of click or select it there. We're getting all of the vertices of this boundary polygon, and then we're just finding a random one. So we're just saying, hey, give me a random vector 3, which is from the vertices array between 0 and the number of vertices in there. And what we can do is once we've found that random one, then we can actually instantiate objects based on that kind of position here, which we're using for plugging in that vertex there. So that's kind of, if you're familiar with what Pokemon Go is doing right now with ARCore, they basically, you find a plane, they spawn little grass tufts on random vertices on the plane. If you click one of the grass tufts, a kind of Pokemon comes out, similar things like that. And so what they're doing is they're saying, hey, restrict all those tufts to this exact plane that I've found, kind of looping through the vertices through there. For ARCore, if you, again, want to just loop through, randomly find a vertice on the plane that you're looking at or that you've selected, this is kind of the method to do that. And again, it's this call of get boundary polygons called on the plane that you've found.
Like the name, does that mean exactly on the edge of the, or does it mean when you receive?
You know what? That's a good question. It probably only means on the edge. Or, that's a good question. Get a list of, in clockwise order, in Unity world space representing a boundary polygon for the plane. Boundary polygon. Well, this is going to be where the food spawned. So yes, I think that's what it is. So this is actually getting specifically the boundaries. Let's see what else we could get here. We could do get a list of points in clockwise order in Unity world. See, it says boundary polygon. Yeah, it could. I guess it could just be the edge ones. I feel like I have seen food spawn not at the edge, but yeah, good call out there. All right, so in order to hook up this food, we have 15 minutes left here. What we're going to do is we need to create a new tag because it's being called through tags in code. So we need to go to tag here in our. It doesn't matter what we're looking at. We just need to go find an object in the scene. Go to tag, hit add tag, hit this little plus, and then type in food. And this does need to be lowercase f. So to do that one more time, click on anything, tag, add tag, hit the little plus button, and then type in food. All right, a couple more steps here. So you need to click on anything, you hit tag, and then there's an add tag button.
Now what do we do with the tag?
Nothing right now, it's all called through code. Although we will be referencing it here momentarily. So what we want to do now is we want to go back to our scene controller and we want to go into our set plane function. And for this, we're just going to get the component of food. We don't actually need a reference to it. You can say get the food controller. And then on here, call set selected plane with our plane that we're passing in. So this is how we're passing that plane once we've kind of touched on it to the food controller in order to get those boundary polygons and kind of spawn things around the edges there. All right, so again, this is just in the scene controller. We're just doing a get component because the food controller is on the scene controller already in our scene. So if we go in our Unity scene here, we go to our scene controller. It has this food controller, and now this is where we need to populate the models that we're going to be using. So you'll notice here, public arrays have this little drop down. So for this one, I'm going to set a size of 3. And then I'm going to go up here in my Codelab prefabs under the food one. We want to make sure that we're using these food, not the actual models. We're going to say apple in there, banana in there, and pizza in there. You could add as few or as many as you want. You need to have at least one. I really like pizza, so they want to add 2 pizzas there. But again, for this step, we have gone in our scene controller, done this single line inside set selected plane to pass the plane to the food controller. We've gone back in our scene here and populated this food models array. All right, we're fastly approaching the end. So the next thing we need to do is we need to create a script that's only going to handle the collision of the snake running into the food. So we're not going to attach this to any object in our scene. Instead, we're just going to attach it through code. So to do this, we're going to right-click on our project, create a C# script, and we're going to call this one food consumer. And once we go ahead and open this up, we're going to go ahead and delete the update and the start function. And instead, we're going to, let me make sure I got this here. We're basically going to do an onCollision enter function. Yeah, so I'm just right-clicking in my project, create C# script. I'm calling it food consumer. I pop this open, and we're going to do the basic collision function here in Unity. Make sure you're passing in a collision, not a collider. And then we're going to say, hey, if the collision that was passed in here, if its tag is equal to food, and that's what we typed in earlier, then set it active as false. So basically turn it off. And then we're going to say slithering s equals get component in parent. And this is something, this was probably the longest kind of gotcha that took me forever to debug, is that the slithering component is going to be in a parent. We can't call a simple get component. We need to be referencing parents here. And if s is not equal to null, then we're going to call add body part. So this is all in food consumer. And then the very last step before we build and run is we need to add food consumer basically to the snake instance after he spawned. So we need to go back in our snake controller, and at the bottom of this spawn snake function, we need to say snake instance, add component, food consumer. Whoop, food consumer, not food controller, like that. And then you guys should be able to build and run. What you do is you locate a plane, you click on the plane, and you'll see a little snake object, and he's actually going to follow the little disc, that's the gaze pointer there, and then you should be able to collect a little food, and as you do that, you'll gain like a longer body.
And we need to add the food tag to the prefabs, right?
No, that's happened through code. That happens through code. So we just need to add the food tag to the project. And if we go back in here, one quick check before you guys build. It's always good to check your prefabs. So we have gaze pointer. We have a snake. The snake has his body prefab, his snake head prefab, his gazer pointer, which is in the scene, the first person camera. If we go into the scene controller, you'll see we have tracked plane display, first person camera, snake controller. So this is a step that I completely forgot. So we need to go and add that snake right there as a reference to the scene controller. And then I think this should work. I've never tried it skipping the scoreboard, so I'm curious to see your guys' results. Remember to just link up that snake controller in the scene controller. And if you guys want me, I can pop open the other script that we had there. So we have food consumer. That's the collision that's happening. We add the food consumer to the snake instance after the snake is spawned, so in the snake spawn script. right. Show me some snakes. I mean, so I didn't build this project, but yeah, I mean, I think it's just so you don't have to go in. Yeah, but and also adding.
Adding more prefabs.
Well, so adding the tag is part of like the steps. Hey, add the tag. If you had to go drag those things in and tag all those, then it's could be a little tricky there.
So the gaze stuff. So this is the gaze.
Yep, there you go. Yeah, so go and eat that banana. There you go. Yes, it works. It works on this guy's machine. So there's a pizza. Bam.
So why is the velocity change compared to where it's actually?
So it's kind of lerping towards it, and it's using that speed variable. Yeah, it's lerping, and then it has a little bit of a thing where the head is trying to not. There's like a little buffer between the head and the gaze thing, so it doesn't like kind of freak out or start spinning around. Food controller, yes. Food controller. So we did the set selected planes, and we did a whole bunch of variables. So what part do you want to see? Sweet. How's it looking?
Waiting for the deploy.
Nice.
This laptop always a problem with the Android connection for some reason.
Yeah.
Debugging, things like that, right? Do you put some kind of bar or something like that where you put debug standards?
Totally. I do that in AR and VR. It's super helpful to basically have either messages or anything always there on screen. With ADB, you can actually put debug logs in there and then get those. You can put a Unity flag to get the specific callbacks. So you could have a command line or a terminal that's basically outputting what's happening on the screen, and that'll give you null references, things like that. But yeah, I strongly suggest in AR and VR to just put a UI object on the screen or in the world, and then just print stuff out to there to check random states of objects.
Anything else other than ADB that uses just for debugging? Like, I've noticed that you don't use AR remote here, you don't use any other stuff. Like anything else you suggest in terms of speeding up the workflow?
Yeah, I mean, I think just there is, so AR interface has something where it kind of spawns fake planes in the world, and you can kind of attach objects to those. In general, if you can basically apply or write some logic in the editor so you don't have to deploy, you can have a raycast that just attaches something to a plane, and then you're like moving that gaze pointer around with your like WASD. You know what I'm saying? Like there is stuff that you could do, or you could just have it where you're just rotating the camera in the scene as well. So really any sort of tooling or things you can do to emulate what a device might do. Like when I was debugging that little wink on those little cuties, I'm just checking, I'm just dragging the camera close to it. Does it do it? Yes. You know what I'm saying? Like you don't need to deploy it to the device. I'm just checking the distance between the camera and the cutie. I can just hit play in the editor. ARCore is going to spew a bunch of errors, but it's not preventing the app from running.
So go back to the you see there are problems.
Sure.
There are problems. It's not compiled. Still all the
Yep.
you need to fix the problems, and then you will see it over there.
I'm getting a weird error where I had this line in the food controller
Yep.
here, and then I moved it, but it's still finding it there, and it's giving me an error saying that claim doesn't exist in that context.
I would say sometimes just like close out of the IDE, and sometimes it's weird about saving things. Let's just, okay.
Could we open the project?
Yeah, let me just try quitting this. Yeah, that's what I'd say. Any other random questions or anything like that? Yep. Yes. What is that? It's time to go. It's 3:30. That was scary. The trick to do that is basically you adjust the, I think it's the vertex shader inside tracked plane display. If you go and find the blog that I posted, there is a call out specifically to that. Let me find it here. We do put out lots of blogs, so it is easy to miss some cool stuff like the one I made here. All right, so this is, I have another app that actually takes advantage of environmental lighting. So you can kind of use that as a driver for interaction in your scene. When he's dark, he gets sad. When the light comes on, he gets a little bit happy. There he is, kind of chilling. Yay, light energy. This is what I'm talking about here. So this is just when you replace the texture with a heart texture. If you want to have this transparency here that you're seeing there, you need to adjust the fragment shader, sorry. So instead, right now, it's returning a fixed 4 based on the red channel of one of the colors that you're getting there, as well as the texture. And so instead, you can just return the grid color times the color, and that'll get you similar results. You can also basically restrict what colors you want. So this is called from an array that I showed earlier from there, and you can either put in some or not. If you wanted like them to only be red, white, and blue, or whatever. This is oriented feature points. I didn't make this. This is from Google's thing. This is that X-ray thing I kind of showed there. You can see me X-raying through a wall in my apartment. And then here, so you can see because he's sad, because he's light. And then when I turn on the light switch, it actually kind of updates from there. And then motion tracking, you guys saw that. And then I showed this one as well, so you can kind of see how that works. So you can just search ARCore blog, or potentially my name or something, and you might find it. It's on blogs.unity3d.com. And finally, I wanted to show you guys this before you go. Also, please don't steal devices. But this Codelab is available online. It goes through a lot. It basically goes through writing every single line of code. I obviously gave you guys some stuff to kind of speed up the process. I do really appreciate you guys coming. We have some very special swag from Google. It is ARCore and Daydream little metallic pins. So if you guys don't steal devices and return all those, you guys can definitely get both of these. I really appreciate you guys sticking through. So yeah, thanks a lot. So cool.